Hello everyone, today we will be discussing about the two-sum problem. So basically in this problem we are given with an array of integer called nums and another integer called target. Now we have to return indices of two number such that they add up to the target. We have also told that there will be an exactly one solution and we cannot repeat the same element twice. Okay, we can also return the answer in any order. That means if 1 comma 2 is our answer, then we can also return the solution in 2 comma 1. It means the order is not same. So let's quickly go to the solution. So here first we will discuss about the brute force approach. So in this brute force approach, we have taken an array and a target 8. What you will do in this brute force approach, you will first go to the first index. Okay, and now you will subtract the element at this index with the target. So 8 minus 2, that will be 6. Now what you have to do, you have to search for this 6 in this subarray. Is this 6 present in this subarray? No, it is not present. So we will ignore this. Now what we will do? Now we will increase the index. We will go to the first index. Again, we will subtract this element at this index with the target. So 8 minus 4 equal to 4. Now we will look for 4 in this subarray. Is 4 present in this subarray? No, it is not present. So this is also not our solution. We will go again and increase our index. Now we will come at the second index and the element is 3. Again we will subtract this from the target. 8 minus 3 will be equal to 5. Now we will search for 5 in this subarray. Is 5 present in this subarray? Yes, it is present. And at what index? It is present at the third index. Okay, and we are currently at the second index. So our answer will be 2 comma 3. What do you think will be the time complexity of this approach? So for time complexity, first we are iterating one by one over all the element. We are increasing it. Okay, and for each index or for each element, we are also looking for the subarray, right? So we are iterating over the array two times. Okay, so the time complexity will be O of n square. And what will be the space complexity? Since we are not using any extra space, it will be O of 1. Now, if you give this approach to the interviewer, he will definitely ask you to improve the time complexity. Okay, so let's jump to the second approach, what we can use. So let's discuss about the hash map approach. It's a joke in the coding community that if you don't understand the problem, just throw the hash map and you will arrive at something, if not answer. So let's discuss about this. So again, we will start at the first index. We have 2. We will look for 2 in the hash map. Is 2 present in the hash map? No, it is not present because our hash map is empty right now. If 2 is our solution, then what element needs to be present in the array? That will be 8 minus 2, that is 6. So if 2 is the solution, there must be 6 that is present in the array, right? So what we will do, we will push this 6 in this hash map, and we will also, this 6 will be our key and its value will be, it's in will be the current index, that is 0. That means if 6 is present in any other index, we can quickly check in the hash map and we know that since 6 is present, there must be 8 minus 6, that is 2 present in the array, right? Now let's go to the next index, 4. Again we will check, is 4 present in the hash map? No, it is not present. So what we'll do? Again, we will do 8 minus 4. That will be 4. Again, we will put this 4 in this hash map. This will be 4. This will be our key. And what will be the value? Value will be the current index, that is 1. Again, we will increment the pointer. Now our pointer will be pointing at element 3. Now, is 3 present in the hash map? No, it is not present. So what we will do? We will do 8 minus 3, that will be equal to 5. And we will push 5 here, 5 in the hash map. So our key will be 5 and our value will be 2. Again, we will increment the counter. Now we are pointing at index 5. At the index 4, the element is 5. Is 5 present in the hash map? Yes, 5 is present in the hash map. And so that means that there must be 3 also present. Since 8 minus 5 is equal to 3, so 3 is also present. So we reached our solution. What is the solution? Solution will be the value of this key, that is 2, and the current index. The current index is 4. So, sorry, 3. Hmm. So again, we will increment the pointer, and now we will be. Arey bhai. So again, we will be increasing the index. So now we will be pointing at the element 5. Now, is 5 present in the hash map? Yes, 5 is present. That means we reached our solution. Now, what will be our solution? Solution will be the value of this key, that is 2, and the current index. Current index is 3. So 2 comma 3. 2 comma 3. This will be our solution. So in this approach, what do you think will be the time complexity? Now, in this approach, we are just iterating over the each and every element just one time. So our time complexity will be O of n. And what will the space complexity? Space complexity will again be O of n. Why it is O of n? Since we are storing all the elements in a hash map. So that's why the time complexity will be O of n. Now let's quickly go and look at the code.
So this is our solution in Swift. First we have created a hash map. Then we are looping over the array. We are checking if the current element is present in the hash map or not. If it is present, then we are simply returning the last index and the current index. Then in the other case, if let's say the num is not present, then we are just storing the current index. If let's say there is no such pair exists in the array, then we are returning a -1. Hope you guys enjoyed this video, and if you have any doubt or query, you can always write down in the comment section. Don't forget to like and comment. Thanks.